Hey everybody, this is Miss Eisencraft with Unit 2, Lesson 19, Practice Problems. All right, number one, here's an inequality. They want to know which of these values of x, when you plug in, would actually satisfy this inequality. So if we actually plugged all these in on the left and the right and saw if it made a true statement after you evaluated it, that would be a lot of work. So what you can do instead is you can solve this as if it were an equation. So replace the inequality symbol with an equal sign and just solve. So what you would do is if we want to solve for x, let's first clear this fraction or get rid of this division of 2, multiply both sides by 2. Double the right side, 6x plus 4. Now solve variables on both sides. Move the x term over. X plus 6 is equal to 4. Subtract 6. So when x is negative 2, when that is plugged in here and here, it makes the two sides equal. And this inequality is wanting the left side to be less than or equal to. So let's go ahead and model this on the number line. Negative 2 actually works, because when plugged in, it makes the left side equal the right side, and that's okay for this inequality. So let's test some of the other numbers. Let's kind of like reason through. Do you think a lot of other numbers will work? Do you think smaller numbers than negative 2 will make an answer that's less than, when you plug in smaller numbers, it will make an answer over here that's smaller than the right? Or do you think bigger numbers? It seems like smaller numbers plugged in over here would make smaller answers. So let's go ahead and try a smaller number, negative 3. Let's plug it into the inequality and see if the left side actually makes a value that's smaller than the right. So we'll plug it in to the inequality, and we're going to see if that's true. So we're plugging a smaller value in than what we got from the equation. You have to do a little bit of math here. Multiply negative 21 plus 6 divided by 2. Is that less than or equal to negative 9 plus 2? Move down here. Negative 15, I'm just evaluating this, divided by 2, is that less than or equal to negative 7? Is negative 7.5 smaller than or equal to negative 7? Yes, negative 7 is further to the left. It is smaller. This is true. So negative 3 is a solution. So all of the numbers to the left of negative 2 will also be solutions. So we can use that to kind of see which of these are going to work, because this represents all your solutions. Is negative 3 in our solutions? Yes. Is negative 2? Yes. Negative 1? No. 0? No. None of the positives, because those numbers would make numbers that are bigger and would not satisfy this inequality. Okay. Next problem. This is a PDF, and it printed this off all weird. That, I think, according to your book, that as a choice. Okay. Find the solution set to this inequality. So we want to know what values of x would make this true. So we're first going to solve the related equation, replace the inequality with an equal sign, the inequality symbol. Okay, and then let's solve for x. Multiply both sides by 2. So we are figuring out what value of x would make both sides equal each other. Okay, move the x term over. 2x minus 6 equals negative 5. Add 6. 2x equals 1. Divide by 2. X equals 1/2. So when x is 1/2, the left side equals the right side. But we want the left side to be greater than, and it doesn't say or equal to, greater than. So 1/2 is like the boundary. So let's go ahead and, I know like 1/2 is like right here. I'm going to leave it a hollow circle. So 1/2, like everything up to 1/2 works, either everything below it or everything above it. So let's look at the inequality and kind of reason through it. We want numbers plugged in for x that would make an answer that's bigger. So it seems that numbers that are bigger plugged in over here would make answers that are bigger. So let's plug in 1 and see if it works into this inequality. So then we can see, are all of these solutions or all of these? So I'm going to plug in 1 here and here and see if it actually makes a true statement. So does 2x minus 3, we want that to be greater than 2x minus 5 divided by 2. When I plug 1 in, so this number here, what do I get? 2 times 1 is 2, minus 3, is that greater than 2 minus 5 divided by 2? Just working it out. Is -1 greater than -3/2? Is -1 greater than -1.5? It actually is. It's further to the right on the number line. -1.5 is over here. So since 1 was a solution, that's the number we plugged in, that's what we were testing, all of these numbers are solutions. The bigger numbers bigger than 1/2. So all the numbers, all the values, so we can represent that by saying x, all x values greater than 1/2, all x values greater than 1/2 will satisfy this inequality, and that is letter B. Okay, let's try number, you don't have to do 3. Let's try number 4. Noah is solving this inequality, excuse me, by first solving this equation. So he replaced the inequality symbol with the equal sign, and he got x equals 6. How does that solution help him solve the inequality? Well, 6 tells you what value of x would make the left side equal the right side. Okay, I'm going to do a hollow circle. But we want the left side to be bigger than the right side. So then you could tend to reason that, well, shouldn't the numbers that are bigger than the number that made them equal each side work? Shouldn't, if we plugged in numbers that were bigger over here, shouldn't I get a bigger answer over here? That seems like it should work, but you could always plug in and make sure it works. So if 7 works and gives you a value on the left that's bigger than the value on the right, then you're good. So let's just try this. 7 times 7 is 49. 49 plus 5. Is that bigger than 2 times 7 plus 35? Is 54 greater than 49? Yes, it is. 7 is a solution, so all of these are working. So that solving the equation helps you find the boundary. And then you can either reason or plug in to see which side of that boundary holds the solution set, or all of the solutions. All right, another one. The equations aren't the easiest, but you guys can handle it. Okay, which graph represents the solution? Well, I'm going to solve it a little bit. I'm going to simplify it. Okay, so let's, instead of solving the inequality, let's solve the related equation. So let's replace that with an equal sign. Okay, and then let's distribute. What value of 5 plus 8x will equal 6x plus 12? Okay, let's solve. Move your x term to the left. We have 5 plus 2x equals 12. 2x equals 7. Divided by 2. You might go, 7 can't be divided by 2. Sure it can. It's 3.5. just not nicely. Okay, so when x is 3.5, the left side equals the right. Okay, so these have dots at 3.5. So it's not A or B because those have dots at negative 3.5. So what values could we plug in for x that would make the left side smaller than the right side? Well, since we want this side to be smaller, it seems that the numbers that are smaller would make a smaller answer over here. So we could always test one, like we could just test 3, because that's to the left of 3.5. If 3 makes a smaller number than a smaller value over here, and when you plug it in over here, then these are the solutions. So 5 plus 8 times 3, is that smaller than 3 times 2 times 3 plus 4? Sounds a lot worse than it is. Is 5 plus 24 less than 3 times, I'm doing order of operations, 6 plus 4? Is 29 less than 3 times 10? Yes, it is, just barely. Okay, so these are the solutions. Okay, 2 more. A review of systems. Okay, solve this system of linear equations without graphing. So it looks like it's set up for elimination. You could subtract them, but I'm just going to multiply this bottom equation by -1 or make everything opposite, which is legal to do, so that the x terms will cancel out when I add them or combine them. So I'm multiplying this by -1. So the top is not changing at all. The second equation, everything is turning opposite of what it was. Even the positive 30 there at the end is turning to a negative 30. Now when I combine them, add them, the x terms eliminate, and I get 8y equals negative 32. Divide by 8, and I get y equals -4. Don't forget, in a system, you need an x and a y. We just found out y. So now for x, you could plug it into either equation. The top one looks pretty easy. Plug in the -4 in for y. Now, that's going to be -44. So 7x minus 44 equals -2. When you add 44 to both sides, you get 40. When you add 44 to both sides, you get 42. So it looks like x is equal to 6. You can always verify that in Desmos by plugging them in. All right. Last one, number 9. Okay. The principal of the school is hosting a small luncheon of her staff, blah, blah, blah. Okay. So she's going to prepare 2 sandwiches for every person. Some staff members are, okay, who cares about salads and beverages? She has a budget of $225 and expects at least 16 people to attend, and the sandwiches cost $3 each. Okay? So from here, it says select all of the equations and inequalities that could represent the constraints in the situation, where n is number of people attending and s is number of sandwiches. So is the number of people expected to be greater than or equal to 16? Yes. Is the number of people supposed to be greater than or equal to 32? No. Is the number of sandwiches less than 2 per person? No, she's making exactly 2 sandwiches per person. So that would be this one. She says each sandwich costs $3. So we're going to multiply $3 times the people or $3 times the sandwiches. And that needs to stay under the budget. So that would be this one. Those were close. All right. Good luck.